We have a plan for today, working on assembly language. The assembly language, and we're going to be using ARM64 instructions, which are like supposed to be simpler. We're going to be trying out some assemblies today, some potential danger with assembly, right? Because with assembly, you could potentially, you can cause issues with it. Hey Joe, how's it going? ARM64, yes, we're going to be programming an ARM64. We're going to be building some assembly code. I have not done much assembly ever in my life, and just a little bit over the years. This is mostly x86 instructions though, and in this case we have ARM. We're going to be doing ARM instructions because we've got an ARM processor, and so it makes a lot of sense to do that because why not? It's time to go. Time to get hands-on in assembly. So mostly it's going to be a learning session. We'll be learning together. I'm kind of curious. One of my main goals here is to make sure that I learn how to do like a for loop. I'd like to be able to do a for loop and then maybe some multiplication, right? I know these are like really simple things that you have in most languages. There's a for loop, no problem. They make them really easy. And within the assembly, I think it's going to be a little more tricky, just a smidge more tricky. We're going to try it out though. I'm actually really excited. So that's the plan for today. That's what we're going to be working on. While we working on assembly language, I'm kind of excited because first we'll walk through. So I created a Hello World repo that is here. I'll paste this into the chat if anyone's interested in following along. Hello World. Here we go. Paste that in. Paste. There we go. And this has just a baseline, and it only works. It's currently I created this build script. It only works with this linker. It only works on my Mac. So it'll if you have a Mac, then it might work for you. But if not, then you'll have to have a different linker, and you have a different architecture. And also if you have CLang installed or a different compiler, you'll have to use that instead. But this works on my system, so we'll get started with this, and we'll see. So we've got a goal. So what's the main goal? The main goal is we've got 3 goals. So three total. We want to walk through. Do a walkthrough of how this works, and then let's see. This is goal number 1, and goal number 2 is a for loop. And then goal number 3 is, we don't want to get crazy with the if. I just want to do multiplication. Multiply 2 numbers. I think that would be really neat because then eventually I know this is overkill, but wouldn't it be neat to have like a little miniature feed forward neural network written in assembly? I think that I know it's completely unnecessary, but I think it would be kind of neat just to get kind of a hint of some ideas on how to do that. I think that would be really cool. I'd be excited to give that a shot. But this is so we're going to start off by walking through sort of this Hello World stuff real quick. This is what we're going to do really quick. So there's I noticed straight away there's something called sections, or at least this idea with these dots and these dot notation. So like you see dot data. The data section is for initialized data like our string. We just started off. We've got 3 goals for our assembly because we're learning assembly. And so I want to walk through this Hello World, and then we're going to do a for loop or multiply, and we want to multiply 2 numbers. So can I just call it that, or is that just going to cause a problem? I'm actually kind of curious. So I'm going to try to build it really quick. It doesn't like that. Okay. The assembler did not like that. Hello. LD cannot. Yep. Okay. That makes a lot of sense. All right. So it has to be data. And so I'm guessing this is sort of like if you're in like any other kind of like a C language, Rust, or maybe even JavaScript. I think this is like the const, like a string val equals like and that, right? So something like that in a different language would be the data section. So it defines static data that will be compiled into the binary directly rather than it being computed or at runtime or constructed at runtime. This is something that's always embedded into the application. That is my guess. I'm pretty sure that's the case. Hey Christopher, hey, how's it going? Good to see you. We're just getting started. We got ourselves up our assembly. We got ourselves a compiler and a linker, and we can actually run a program. So we're good to go. And we have to be careful. You gotta be careful because there's a potential for making a whoopsie. You could whoopsie this and cause your computer to crash. Probably, I'm guessing, because you're accessing like the very low level code here, and it's very possible that you could do something that causes a crash. And if that happens, and the stream, hey, thank you for the likes, appreciate it. Thank you for the reactions. This could cause a stream to crash. If it crashes, you'll know why, because we did a whoopsie and we ran some code that caused an issue. We've got a static, and then also it's very interesting that there's this here. Like, I'm wondering, and does it have to say .ASCII? I suppose you have to say what kind of static data this is going to be, and it says this is ASCII static, and then hello lang, and then hello, and this is a hello string. So I'm kind of curious about this. So this is really weird. I don't know. I don't know if I can read this very well, but basically it looks like we're defining this variable hello string, and there's also the length of the string here, which is interesting. I don't see how that works. And so this is the static variable, the static data. And this is the hello string is the name of the variable, and then the length of the variable. But there's an equal sign, a dot, and a subtraction sign. What's happening here? I don't know. I don't get it. But there's also this text section contains the executable code, which is interesting. But there's this global section. I think this is required. So let's see. Start is the entry point for the program. Okay. This is where the execution begins and must be defined as a global symbol. Okay. Interesting. So this is a require. So if we actually got rid of start, or what if I guess we could name it something different, right? I wonder if we can name it something different. What can we get rid of the underscore and call it something different? Let's try to build that. No, it has to have an underscore. So the start of the entry of the program, it must be defined. Oh, wait. Is that because of the code comment? Hold on one second. Here. Oh, wait, I think I screwed it up. All right. See, it looks like the octothorpe is code comments, but it's actually a symbol, I think. I think the octothorpe is a symbol. Here we go. Oh, sweet. Okay, so I got a different error now. Undefined symbol for architecture underscore start reference. Hold on. Did we get this somewhere different? No, I don't see it. Okay, so that works. So it looks like, you guys, that it's necessary to have the underscore start. I would like to be able to have control over that. I feel like I want to be able to change that. But, also, I noticed that there was this P2 align it didn't seem to do anything. Aligns the code to a 4-byte boundary. So this is what this does. And it didn't seem like if I used it or not. Hey, Christopher, I'm still amazed that Chris Sawyer wrote an entire game. The Roller Coaster Tycoon was written in assembly. It was? Really? That is impressive, because I'm struggling. I'm like, I've been programming for decades, and assembly is challenging. We're currently going through assembly. We're learning assembly language today. We'll be walking through a hello world, and then we're messing around with it. We're changing some variables and seeing what breaks and what doesn't. And I'm kind of excited. So Christopher, you think there weren't today's ability to patch on the fly, so it had to be 100% correct before release? Oh, right. That is all right. So you actually make a really good point, because assembly, it looks like there's so many opportunities for mistakes. And to get everything perfect on the first release, we're going to walk through the hello world. So we got kind of through the first part. I want to do the walkthrough, going to try to do a for loop, and then a multiply. Sean, I heard if you already know C, it's easier to learn assembly. Thanks for the likes, you guys. Yeah, I think so. So I already know C. I know C pretty well. And Malix and seg faults and it crashing and using GDB to debug and backtrace, like GDB and backtrace on your core files. Your core dumps. Yeah, I remember those. It's like, I don't necessarily miss those days, but they were fun, and it was actually kind of cool because you were building code that was really fast and really performant. But danger mode, right? If you're writing in C, you have a high chance of crashing as well. So you have to be careful. All right, so let's see here. Call the right. Oh, thanks for the likes, you guys. Appreciate it. Hello string, hello length. Okay, so this is what I'm super curious about, is this length. Doing good here. We are currently walking through assembly language. We're going to give it a try. We're doing a quick hello world call, number 4, which is a syscall for writing. So I guess for output, for writing output, and a file descriptor, number 1, for standard out. I totally get that. You can open up a file descriptor to write to the disk, and it will be some operating system based number. So you can call, it looks like you can call operating systems commands by doing this. Now load the base address of the hello string label using ADRP. All right, so this is, I don't know. I'm not sure. Is this a register? What is this? What is X1? X1 is now the page address for hello string. Oh, X1 is, it contains the page containing, okay. Containing, yeah, okay. Considered a base address. All right, it feels like a register of some sort. And then add, okay, so now add the offset to get the final address. We do stdin is 0. So it's 0. And std out is 1. And then std error is 2. So if that makes sense. So if we were going to do a read, we would want to change that into a 0. Do you need help? Yeah, I do. You can tell I'm struggling right now. I've not done assembly before. I've done lots of programming over the decades. Olivia Coder, any backseat driving, totally welcome. Anything that you have to say? Yeah. Oh, cool. Absolutely. We're learning assembly for the first time. I've used assembly, but I've never really written assembly. I've never really needed to. I understand now. Thanks. Yeah, absolutely. Happy to help. Yeah, so you can see that there's these different file descriptors, and there's some operating system bases to get has different numbers. What is number 3? Is number 3 the beginning of any? Let's see. And 3 is for files open, reading, and write. Okay, so yeah, all right. So it looks like 3 and above will be file descriptor numbers that you can use to read and write to direct to files. What is network I/O? Network I/O is going to be, well, I mean, it could be any of them at that point. It's just whatever the operating system is going to give you. What are you trying to achieve? We are learning assembly. Olivia Coder, we are learning assembly. We want to, here's the goal for today. Here's the goal. All right, so we've got goals. First goal is to walk through the Hello World program, which we're kind of doing, and we're fiddling with it a little bit. And with fiddling, we're trying to see what breaks and what's possible and what's not. Like the data section, pretty sure it's constants. Text, not sure. This start seems to require you always have to have a start. I'm curious about that. I have no idea. I tried to change it, but it wouldn't let me. And the second goal is we want to do a for loop, and then the third goal is we want to multiply 2 numbers and print it out. Expects a underscore start. Okay, so you need an entry point. Olivia, that explains it. You need an entry point. So here's the underscore start, right? So here is the underscore start section. It expects it. It's required for it looks like the linker, so the linker can find it, which makes sense. So you can build it, but you won't be able to link it unless there's a start because it won't have an entry point. Welcome back. We're currently working on some assembly language. Oh, mutable. You're bad. Oh, not musical. Data is mutable data. Is it? Is it mutable? Really? I didn't know that. I guess it makes sense because you're in assembly, so there's really no concept of like a static data. Everything is just fluid, and you can do whatever you want, right? Did that totally make sense? If you're used to C, then you know main. All right, main. Okay, yeah, main. Yep, that makes sense. So main would be the start in that case, right? So you've got main here in the start, and well, the main functions normally get called by start from the linker. Oh, see, the puzzle pieces are going together. Dara in gas is const. Oh wait, what? Really? Oh really? So you can have const. So read only. Data. Read only data. Really? You can have const. No way. That is so cool. Okay. So then how do we, let's define a let's define a number here. Let's do, so Olivia Coder, this is awesome. Thank you. Let's do read only number with value of 42. Let's do it. Let's do value of 42. How does that work? Okay. My number is 42. Do we have to have this align here is what my question mark. 100%? That is so cool. I didn't know that. We're learning new things. So we got data. And then in assembly, you can have read-only data. You can have static data. That is so cool. I like that. I'm actually kind of curious. 100%. This is awesome. Appreciate it. All right. So I'm actually kind of curious. Will this build? Will it build? All right. Let's try to build it. .ro data LD cannot open unknown directive. Unknown directive? Oh, come on. Really? It doesn't seem like unknown directive to me. It seems like that should work because this is RO data, right? Read only data. Let's see. Let's get rid of that real quick and see if it recompiles. All right, looks good. Okay, we're gonna bring it back. Maybe if we got rid of that and then it's good, like that. No. What if? How do we? So quad 8 byte for 64-bit integer 42. See, it's struggling, Olivia. We're struggling here. I want to use this. I really want to try to define a number, and then see what it is. So let's see if we can align to boundary my number, and then read only with the value of 10. Okay. And then what is dot quad? Let's see. So dot quad is for defining 8-bit or 8 bytes, a 64-bit value. Oh, okay. That makes sense. All right. So quad, is this gas or NASM? Dot quad. This is, I don't know. I actually don't know the difference between gas and NASM. Yep. And you want to align with 4. Okay. Oh, align with 4. Okay. Align 4. Okay. Like that. All right. Align 4 because it's going to be like that. Okay, that makes sense. So we've got my number and my other number. Let's see if it builds. We're having trouble with this .ro data is having trouble. Wait, what if we got rid of the .ro? What if we did that? Oh, it builds now. Okay, so I really want to try this .ro. I really think .QUOD is gas. What is QUOD? I'm actually kind of curious. What is QUOD? Actually, let's check this out. .QUWOD is for defining 4-byte. Oh, and 32-bit. Whoa, look at that, you guys. Okay. Oh, wow. Okay, so this is very interesting. See, now this makes sense to me. Like, I understand this number here. You're looking at the screen, you see my number colon, and you say quad, which is going to mean for 8 bytes or 64 bits, and you say the number. Oh, dot sections. Okay, so you've got NASM is different. Sections. Interesting. Okay. I don't know what that is yet, but we're going to find out. Chris, it's so cool that we have an ASM coder on the chat. Yeah, I know. Isn't this helping a lot? Basically, checking other things out. All right, so now we've got this. For whatever reason, this .ro data is not working for us, but we can at least have it in the data section for now, it seems. At least for now, we can have it in the data section. Also, is indentation important? I'm wondering. Is indentation a thing? Oh, I see. Oh, look at you guys. I get it now. Oh, look at this. We're so dead. I get it. I didn't realize before. Look at that. Okay. So you mean you've written OpenGL in assembly? So I think I have some experience. Whoa, you've done OpenGL. All right. So writing OpenGL with that framework in general is already hard as is, even if you're using a higher level language. Like even with C or C++ or C#, you're going to have, it's tough. It's really tough. So it's really impressive that you were doing this in assembly, Olivia Coder. Wow. Guys, saw someone is coding in assembly. Guy happy. Yeah. This is really cool. We're getting closer to the hardware level, right? We're closer to the hardware. It's every step's closer. So this is really cool. I'm actually kind of excited. And yes and nope. Okay. So here we go. So I'm actually kind of curious. Are these two different statements here? Can we do it like this? I'm going to try to build it. It looks like that builds. What if we build it like this? It's easier to read is what you're saying. Okay. So we do see that this won't build. It doesn't like this unexpected token. So we do have to have it like this. It does have to be like this. It's like this. So I get this now. I understand the variable definition part right here that you see on the screen. Interested in assembly programming too? Cool. Yeah, this is really fun. We're checking it out. We're trying it out. This is awesome. I'm loving it. So we've understood how to define variables here. So we can name the variable. You've got a colon, which helps you define like I guess the assignment part. And then you get to say what kind of data it is. Isn't this cool? What kind of value this information is. Welcome, RG. Hey, welcome. It's so cool. Welcome, guys. All right, here we go. Check this out. So we're defining a string .ascii. I wonder if you can say UTF-8. Can we say UTF-8? We're coding in assembly and we're trying it out. We're playing out. We're messing with the numbers. We've got some goals here, you guys. Let's jump back up to the goals. We're walking through a hello world. We're just saying, we're printing out hello world. We're going to learn how to multiply some numbers. We're going to learn how to do a for loop, and we're going to have fun with it. And that's the plan. That's what we're doing today. This is really exciting for me. Alex, hey, how's it going? Awesome stream. Cool. Thank you. Appreciate it. Thank you for the likes, you guys. I see it. Okay. In my computer, it is okay. So we are programming in, so there's one difference here. We're doing ARM64 assembly, which is going to be different than x86. So I've dabbled only briefly, just tweaking some x86 assembly in the past because we use it in production at our company, but I have not directly used it to build anything myself. See assembly, I subscribe. Cool, really? Thank you. That's so cool. That's what we're doing right now. We're doing assembly coding. We'll probably be doing this that's the plan. So today's the plan. We're doing assembly for sure. Having an assembly exam in a few days, and I know nothing. Mine is based on x86. Yeah, x86 is I guess more of the industry knows x86, and more of the industry has already written x86. So there's not as much ARM64 out there because it came out after the compilers were already at high level languages. So you wouldn't necessarily need to dive into into ARM64 assembly, but we're doing it. That's what we're going to do. We're making it happen. So we started about 30 minutes ago. But we're still at the top of the file. Have you noticed we're at the top of the file? We're playing with assembly. We're learning it for the first time. We're understanding the syntax and how it works. And it actually makes a lot of sense. I'm understanding it pretty well. It makes a lot of sense here. Not Owen. Hey, how's it going? This seems like a good for algo. Great stream. Absolutely. Happy to see. I'm excited for it. What language is this for? Multiverse realities. This is ARM64 assembly. This is ARM64 assembly. Most of this, though, can work in, I would say, even x86. But since we're in ARM64, we're going to be using ARM64 instructions, if that makes sense, you guys. Yep, from switches and Intel and AT&T. Okay, yep, that totally makes sense. Aren't most IoT devices ARM? They are today. They weren't always, and some of them were just more dependent on the instructions, but they were microcontroller processors, and I don't know if they were ARM instructions, but they probably ran on a similar or a subset of the instructions that were available. I would like to be very curious to use an operator that is available in ARM, exclusive to ARM. I think that would be a lot of fun as well. But for now, we're just trying to keep it simple because we have these few items here on the screen that we want to go through. So we're walking through a hello world. ADES and AT, can we have a rundown of the code? Yes, absolutely. RG. So here, let's do a quick overview of the code so far. So we've got a data section, which defines your variables. There's supposed to be a read-only data section, but I can't get it to compile. Olivia Coder got me really excited about this read-only, but it's not working. I can't get it to work. So at least we have this data, which is mutable data, so we can modify it later in our program. We've got this hello string, which is this colon is like an equal sign, and then this dot, and then a set of strings afterwards defines what kind of data type it is, what kind of memory construct it's going to be. So it's going to be ASCII, right? And so .quad, for example, is 64 bits or 8 bytes. And you can assign a number to it. So you can see it's basically like the name of the variable, the type of the variable, and then the variable's data. So you've seen this in other programming languages before, right? In like a different language. So like, for example, in JS, this would be like this. Check this out, you guys. But actually, let's say TypeScript. Let's do TypeScript so we can say in TypeScript because TypeScript, here we go. It would look like this. Const. But I'm running behind because I'm getting really excited about all the assembly on the screen because there's so many fun opportunities here to learn. This is really exciting. So what is your project here? I'm new. Oh, Red Gun 10. Red Gun 10. The project we are working on is a Hello World for assembly. We're walking through. We're gonna learn how it works. We're gonna multiply some numbers, and we're gonna see if we can do a for loop. That's the idea. Here, good docs. You know where there's a dot string. Okay. For example, dot section, dot row, read only data title, dot string. I kind of it. What is dot align? Dot align tells you the boundary. And I don't know if it's necessary. I'm not sure if it's necessary. Let's actually find out if it's needed or not. Let's see here. Build. Hello. Yep. All right. So let's try commenting that out and see if it likes it. It seems fine. The dot align doesn't seem necessary. We can do it without dot align. I don't know if it's going to cause a problem later on. It didn't seem necessary. Let's see here. Var type. Yes, exactly. It's like var type, isn't it? Olivia Coder. Is this live? Text. Yes. Text. Taxi Revenge. Taxi Revenge. Hey, Taxi Revenge. This is live right now. We are live. We are coding in assembly and we're learning it for the first time ever. It is useful. Align 16. So what happens if we do align 16? What will it do? Let's do it. Let's do align 16 and see if the language is happy. We're building it. Warning. Reducing alignment of section data from this to that because it exceeds the segment maximum alignment. Whoa, that's so cool. Okay, so we found, I like this because we're learning the limitations, right? We're pressing the boundaries. This is how you learn, especially in computer science. You give it a try. You're trying things out. You're giving it a try. So what if we do align 8? Let's see that. What happens if we do align 8? It's fine with align 8. What if we do align 1? Is it going to be happy with align 1? It doesn't seem to bother. It seems fine there. We're seeing fine here with align 8 and line 4. Okay. It's useful. It will align to 16. It will align memory to 16 bits. Oh, will it? To 16 bits? Oh, okay. Okay, yeah, gotcha. So, but then how quad is stored if we align to 1? I don't know. I think probably what's going to happen is it's going to reduce the number's value. So if we try to use it later, Debandra Kumar, then I think it's going to not be 42. I think it won't be 42. I think it'll be a different number. I think that's the answer. Are you guys doing? Oh, Sai Topeng. Okay, here's what we're doing. We're learning ARM. We're learning ARM64 assembly is what we're learning. We're going to do Hello World, and then we're going to play. Now it's assembly. Cool. Yeah, it's your guy. Thank you for the likes, you guys. Yep, we're in assembly now. So here we are walking through. So Olivia Coder, feel free to paste that link into the Discord there, the Discord, and then we can read it there. So what we can do is we can open up some of the docs. Sohim Joshi, how's it going? Hey, all right, let me look at your chat message here really quick. You also know assembly. We are learning assembly. I know of assembly. I kind of have an idea of assembly, but check it out. We're learning it together today. That's with a plan. We're learning it together. We just learned about how to assign variables. This is why there's data types. Like if you ever run into a language that's a strict typing language, look, it's the same here in assembly. It's exactly nearly the same. So you can say const hello string as a type string, right? So you can say the type is string, and then you can assign the data. That's what we're doing here. So we're saying hello string, which is the variable name, and then the type of the data, and then you've got the actual literal of the data. Isn't that crazy? And then there's this also, you can do some sort of calculation here, which I'm not familiar with, and I don't understand these symbols. There's an equal sign, a period, and a negative sign. Okay, you pasted from code void OX24. Here we go. Okay, I got it. We're going to click it. Here we go. All right. Assembler directives. Oh, there's an abort. Whoa, look at this, you guys. Oh, there's so many options. Dim? What's dim? This here, I'm going to zoom in so you guys can see a little bit better. All right, what is this? Look at all these options for assembly, you guys. Data subsection. Okay, tells the assembler the following statements into the end of the data subsection, which is an absolute expression. If subsection is omitted, it defaults to 0. Interesting. Okay, def. Begin the defining of debugging information. Oh, interesting. Okay. There's a lot of stuff in here, you guys. Yeah, okay. Let's see here. This is great. I'm planning to learn assembly. Cool. We're learning it together. So some of the things that were not obvious immediately are starting to become clearer, you guys. We're starting to understand some of these things. This is making a little bit of sense. Wait, so you're on a Mac, guessing from the big ARM64 on the screen? Yeah. Yep, we're on the Mac. We are ARM64ing right now. So that will be the assembly language that we are currently writing will be ARM64 here. So we are doing ARM64 today. ARM64 assembly, you guys. ARM64. So I heard it's easier than x86. Yes, so I think here's the idea. So simpler instruction set, right, is the idea. Or even with like RISC, which was like RISC, which is equals reduced instruction set, is kind of the idea. I believe ARM, so you have x86, then ARM, and then RISC. And the idea is just simpler, right? So fewer instructions and that just perform faster. I think that's the idea. Assembly is not run in VS Code. You can. So I'm using Vim here as a text editor. It's just text, right? So you can use any text editor you want. It's no big deal. But then you need to compile it. And so I have AS, which is... it is, let's see here. Let's actually type that correct version. It is just a compiler with, it's C-Lang. It's C-Lang compiler here. So as you can see, we're doing C-Lang here. Apple C-Lang. And then we use a linker with LD to link to the operating system's functions. So you can have baseline assembly here. So assembly is not running, yep, that's right. Gas, it is gas. Yep, you got it, you guys. This is really exciting. And the linker will take all that information you can have in your assembly once you've compiled it. And then it's not a compiler, right? And then it will take it. It's an assembly. Yeah, there we go. AS and it's an assembly. All right. So we're looking at, so there's this text section, which I don't think we need that, right? There's no need for this. I believe we don't, or do we? Do we need that? See, look, it works without it. It seems like we don't need some of these things. The text section contains the executable code. Well, turns out we don't. Maybe let's actually try to run it with assembly language today. We're learning how it works. We're having a lot of fun just to jump in and play with the code yourself. Put your hands on the keyboard and try it out. That's what we're doing right now. Here we go. So we're messing with all these numbers and then we're trying things out. Like I did a line 1. And a line 1 seems to work perfectly fine. I don't know why. Also, we don't need this text. We don't need this text section here. Simone, here we go. If you don't run it with sudo, it shouldn't crash the computer. Well, maybe it's possible that we can crash. It's possible that we could do something by, moving something in a way and accessing some memory that we shouldn't. Maybe the operating system's supposed to protect us. But you never know. You never know. Text section will keep you from messing stuff up. Will it? You need it? Okay. So I'll add it back. It's not obvious. The .text section will prevent modifications of the code at runtime. Will it? Does it really do that? Isn't that interesting? What domain we learning this in right now? The domain is assembly in ARM64. That is a subject of AI. Absolutely. Subject of AI. This is assembly language, and we're doing ARM64 today. ARM64, you guys. I guess the dot and the address of the current line in memory, you subtract the address of the string to get the length? Is that what that is? Oh, cool. Is that what's happening? Okay. That is really neat. All right, so you helped me understand a lot just now with that. This line right here, line 16. So is that how we get the length of the string? That is very interesting. Simone, thank you. Thank you. That helps me a lot. Do people still learn assembly? We are, Tushar Pinto. We are learning assembly right now. Olivia, yep, yes, exactly. Start is like the main in C. Yeah, here we go. So we have the start here. We've got the start, but then we've also defined global start like this. And I think you can just put these two together. And then I don't know about this. It didn't seem like this was necessary. It might be like a default, but like I try to build it and it works fine. And let's see if you run hello. Let's see if we can I'm going to run hello. And if it crashes the system, we'll find out. Here we can also put the (0) on the end of the ASCII. So you have the null terminator. The null terminator. Oh, right. Oh, because, you guys, look at that. And is that necessary? Do we need to do that? It didn't, wait, but is comma like a concatenation? It seems to not like that. The linker is having an issue. File cannot be opened. It is not happy with that scenario. It doesn't like it. Maybe I'm doing it wrong. Maybe it has to be like that. Maybe a white space is a problem. Nope. It doesn't seem like strings are null terminated. Absolutely they are. So like \0, right? You gotta have \0 in there. But what happens if I do that? It seems fine. And then if I build hello world, it works good there. So \0 is being to be null. It helps. Hold up one moment. Okay. Strings are null terminated. Yeah, exactly. They are null terminated. But why is it not? Oh, because we are using a length. We don't need to have a null terminator because we're lengthening the string. We've got the length. So we're only going through this. And so we don't need the null terminator. You don't need null terminators, Olivia. I know this part. You'll look it up. I know that for certainty. You don't need a null terminator if you already have the length of the string. You don't need it in that case. I'm pretty sure, you guys. Use .string instead of ASCII. Okay. Oh, okay. String. There we go. And then .hello world. See, look, it works perfectly fine. It's working good. There you go. That is so cool. Title string OpenGL assembly. Okay. Well, I'm going to type that in, but I don't know what that's going to do. See, title : .string. Oh, this is going to be, so you're defining a variable, a string. Okay. String. And then you say OpenGL-ASM. And this is just a string. We're not null terminating it or anything, but here we go. How to write a whole computer using assembly? Scar. That is like the ultimate question, isn't it? Because we're struggling right now just defining a variable. Just getting a variable. That adds a, oh, does it? Oh, Olivia. This automatically, so this will automatically add null terminator. It does. Look at that. So .string automatically adds null terminator to it. So then we could easily print and we wouldn't need ASM. So we'll do I have tar? I do. Tar extract the archive, the download, ASM game. It's a register. Oh, is it? I was wondering about that. I'm wondering what's a register. Oh, so it depends. Let me catch up. It's a tarball. Fair. Just look at the code. Yeah, we'll be looking at the code. Olivia, I'm just for safety, run it in a sandbox. We totally could. So I could spin up a server and then run it over there, or put it into a container. But the container here, I'd actually want to run it in a separate server because the container on my current system isn't going to be virtualization of any kind. It runs natively on the operating system, and it will potentially still crash. Are we learning assembly instead of just learning high level? Yes, you're right. Blazy, yep, that's the plan. That's what we're currently doing. We are learning assembly. So I will try to open up that file. It's right there. So tar extract the archive. I believe like that downloads, and then it is asm game.tar. Here we go. Ignoring. And is it doing it? Is anything happening there? It's trying. It's making, well, it's not zipped up though. It's just a tar file, right? So how do we, I forgot, tar extract is the tar -- help. Here we go. We're going to see, here we go. Create file name verbose, location of the archive. I don't think we need the use -- IDE is it? We are currently using Vim. This is Vim, Vim text editor. This is Vim text editor. This is the IDE that we are currently using. It is assembly language. So it's like when you write your code in a higher level language like C, you're writing sort of abstractions, and then you'll have essentially a stage where it moves your C code, it translates it into assembly language, and then assembly into sort of like a machine pattern code that then can be used in a linker to link to the operating system's instruction set and system calls. I think that's how that works. I'm pretty sure if that's right. So assembly is the language of the gods. Yes, Space Whale software. You got it. What are you teaching, sir? We're learning assembly. I can't open your tar file, Olivia. It's not working. If we can think of another way to get the tar file, we can make it happen, but it does not seem to open. Max, hey, how's it going? Ah, yes, exactly. What is assembly language? There you go. I think that answers your question. Is it an IDE that is a text editor? It's Vim. Do XZ. Okay, I'm just catching up on some of the chat here. All right. So let's keep walking. Let's keep walking. So this is when you're doing this right here, this is just defining a variable. So this is the title, the variable's title, dot string is of data type, and then here's the actual string. And when you use dot string, it automatically as a null terminator, which is the \0, which you can have multiple null terminators, no problem. And I think it will work perfectly fine. So we're building something here or just learning. We're learning. We want to multiply some numbers. We want to do a for loop, and that's the plan. That's it. That's all we're doing. But we're stuck in the learning phase. And we're getting it. We're understanding some things. So we've got ourselves a variable here. We've got a bunch of variables. So we're defining some variables here. Let's bring that back up here to the top. Boom. All right. So we've got a variable. So we've got a variable, title, string, async. Looks good. This is just regular assembly language, and we're going to be doing it on ARM64. And we're just doing hello world, but we want to do a for loop. So I want to say hello world a few times in a for loop. I don't know how to do a for loop. I'm actually kind of curious. So if we have this information, so we haven't actually gotten to the actual execution part of the code yet. We've only been stuck here at the top with the variables, the defining of the variables. So here we go. We're getting into it. We're waiting for the zip from Olivia, and then we can look through some of Olivia's code in assembly. So we're getting down here. So this is like main, right? So if you've ever been familiar, this is like main in C. It's like this. Like if you've done a main int, it looks like this. An int main, like in C, it looks kind of like this. And that's what this global start is. It makes a lot of sense. Okay, cool. Yeah, learn with projects, avoid video tutorial help. Yeah, so Quantum Quantified brings up a really good point here. If you're going to be learning some new languages, you actually want to get your hands on the keyboard. Get your hands on the keyboard because you're going to learn a lot more. Like this is what we're doing right now. You can watch some tutorial videos here and there because what you're going to do is it's going to give you an idea of what's possible, but you won't actually learn until you get your fingers on the keyboard and you actually start typing. You want to start typing, right? So that's what we're doing here. Call the system write on number one, which we learned is standard out. This is the file descriptor. Number one is standard out. Here we go. Number one here on the screen, number one. So we can see that is standard out. And these number symbols here, is very interesting. So move x16, which I'm not familiar with this. I don't exactly know what's going on, but now we're getting into the instructions. We're kind of entering in the future where most of the time we're using ChatGPT to write a lot of the stuff for us. But if you want to learn, it's still best, right? Space Whale, you got to make sure to get your hands on the keyboard. So move x0. I'm not sure. What is x0? X0 is the first argument to the system call. Oh, is it? Wait, what? Really? No. Wait. So move, what is move? Move is used to move immediate values into registers. Oh, I thought this was the case. I thought X0 was a register. So is X0? X0 is a register that holds the first argument of the function call. Oh, whoa. We're learning. Things are making sense, you guys. This is starting to understand a little bit more, you guys. Here we go. So use ChatGPT as a guide. Use ChatGPT as a guide instead of code completer. If you're learning. Yeah. So that's what I like to do is using the AIs to help you learn a little bit more. But it's getting your hands on the keyboard. Learning assembly. So assembly. We're learning assembly today. Okay, the zip is there. So ASM game. So let's do that in our terminal window. So let's do over here. We'll go CD downloads. Here we go. ~download. Downloads. And then we'll say unzip. And then unzip is unzip. Yep, unzip is installed. ASM. Here, let's grab that and copy and paste it, you guys. Copy and paste. There we go. Copy and pasted. Olivia, what are you doing? What is going on here? You do C++ and assembly and Java. Cool. Yeah, these are the core languages for the past several decades that are used in and C++ is still heavily used in AAA games and game studios. You'll sometimes use ChatGPT as a sanity check. Very good. How did you learn this much language? Over the years, you run into a lot of languages and you want to learn different things for different scenarios. You want to try things out because the more you try, the more you learn. And there you get knowledge that you can bring back into other languages as well. Because all languages are pretty much the same. They'll have the same design patterns. But once you find out one really cool feature of some languages, like Rust, my favorite feature in Rust are the match statements and the requirement that you have to match all the possible every possible sort of possibility. Otherwise, the compiler will prevent you from compiling the language, which is like a really nice check. Which is why I like Rust. So do LASM game unzipping on the GUI. Oh yeah, I guess that would probably work. Unzip this in the. There we go. Yeah, no, just using computers here, you guys. All right, so it works now. All right, here, now we can go back to the terminal. Now, thank you for the likes, you guys. I appreciate it. We, yeah, fair. Yeah, CD, what was it? Where is it at? Let's see here, L. Look at that. That's a problem, isn't it? Let's make sure that we can get this information here. Let's see if we can, we'll put this on the desktop. CD desktop. Here we go. All right, perfect. It's my fault. It was my fault all along. Olivia Coder, please forgive me. We could have untarred it all this time. It would have worked fine. Here, oh my God, this is so embarrassing. I'm so sorry. Here we go. Let's do this. Check this out. All right, so here's the tar file. Tar extract the archive ASM game tar. There. Oh no, it still doesn't work. No, extract a zip. No, must specify. We'll get that. We'll figure it out. CRT or U. Tar. Maybe is it untar? Untar. Is that a thing? Nope, it's not. Tar extract very fast zip. X was for extract, right? Let's try. We're gonna try one more time, just because I think we need. I think we need to XFB ASM. Here we go. There it is. Okay, you got it, Olivia. Thank you. There you go. We figured it out. Okay, OpenGL. Here we go. OpenGL assembly is what we've got here, you guys. I'm gonna look at your build. I'm just kind of curious about your build. It probably won't pkill triangle. This was the first run. Make clean. Oh, so you've got a make file in here. Yep, you do have a make file. All right, make file. Build. Okay, so here we go. Oh, GCC. Okay, I don't know if I have GCC on my system. We probably won't build it. GCC. Do I have it? Yeah, I do have GCC. All right. 0 optimizer. G for debugger, right? So G, no pi for, what are you doing right now? Osama bin, we are currently looking through Olivia Coder's source code. Olivia sent us a archive that has source code in assembly. And this assembly calls, what's in build? I'm actually kind of curious on what's in build. Triangle. Oh, it's in, so you've already got the binary there, which probably won't run on my system because I'm running on a different architecture. LM is for math. LM is for math. Okay. Matrix 4 is broken. Matrix 4. Okay. CD, SRC. All right. Look at all of your assembly files. Wow. Matrix 4. Let's Matrix 4. Look at this. Okay. Intel syntax, no prefix. If not defined, define it. Set. What is this dot set? I'm not familiar with dot set. You can set matrix 1 to 1. Is this like stack variables or something? Like instead of welcome to the stream. We're currently walking through some assembly language. We're learning assembly for the first time. You use macros as functions. Is that what that is? So Olivia Coder, we need to know. Are functions, can you make your own functions, or is it like go-tos? Like what's in assembly for when you're writing functions? Macros are functions, or are they go-tos for functions, or something else? Like is that the best way to do functions? Like a macro sounds like a really good way to, in this case, execute functions more easily. Right? That seems like it's better. Edward, TY, I'm also trying to learn assembly. Have you already tried Compiler Explorer? I have not. I'm only using the assembler and the linker. Functions are labeled. Okay. Label struct offsets bytes. Okay. Camera size. If not defined, set. Okay. Intel syntax, no prefix. Interesting. Here you go. Here's a macro. Create a camera with the name and a 3-dimensional. Oh, with the pitch, yaw, and roll. Oh, this is the viewport. You're defining the viewport, aren't you? Olivia, this is the viewport. So when you're like looking at a 3D space, the camera is the viewport. What you're currently lacking, what you're looking at in the and what's going to be rendered on the screen. That's so cool. That's really neat. Macros are more like a preprocessor. Oh, so it's actually really useful because then the macro will be compiled or essentially compiled ahead of the time. We're looking through some assembly. We're going to start in main by main.s. Here we go. Oh, look, you can do include statements. Whoa, we're learning more things every day, you guys, every day. Look at this assembly. Isn't this cool? So we looked at the camera, which is going to be the viewport for what we're drawing on the screen. We're probably going to draw a triangle. By the way, when you stuff like glf win in it, that is a clib I'm calling fusion from. Oh, so you can actually already call. How do you do that? Call, here we go. Is this it right here? Call glfl init. So you're actually calling code from another library, and this is linked in, which we saw in our make file, right? Is that right? In our make file? Look, take a look here. Look in our make file to see what you had. Here we go. There it is. You guys, look at right there. Isn't that cool? There's a library that we linked in, and that's how you get that function. You have access to that function. You can call, check it out. You can call this because we linked it in, you guys. Do something else with the stack. Oh, wait. Let me catch up. Assembly is black magic to you, isn't it? Yeah. Ward Martinson. I might be wrong, but I believe functions are abstractions of higher level programming language represented by a jump to another part of the program, like a go-to statement is like the go-to. I believe it modifies the program counter. Ahaha. Yeah, see, that's what we're trying to learn. We're trying to learn that. Call goes out to a predefined function. It's similar to goto. I'm actually kind of curious about that. I would like to learn how to define a function in assembly. I know it's like a higher level paradigm, but maybe a way to like jump to or go to. Learning assembly language. We're learning, thank you for the likes, you guys. We are learning how to read it and write it. So right now we've got Olivia Coder was so kind to give us some of an example of code that they wrote, and check it out. It's really cool. And we can see their make file. We can see what they've linked in. And then we have some of their code here. So we can get rid of GL constants. And then we can see this is, so we have to go back to, let's open up the main RC file, our main S file. Here we go. And this is their code. We are walking through it right now. I'm really excited about it. Like today we're doing assembly language, but maybe tomorrow we'll do MCP. And then maybe the day after that, we'll jump back into assembly. I don't know. We'll never know. By the way, you're using GCC that can use math. Okay. Instead of start. Oh, what? Really? Oh, is that why there's this main here instead of start? You've got global main. Okay, so that's fine. Actually, that's a way better. I would prefer. Why did I use start? Like, why did I use start instead of start? Oh, GCC uses main, but my assembler uses start. There we go. That makes a lot of sense. I'm actually kind of excited about this. There's a lot of interesting things here because learning machine language, or at least, the higher level primitives of machine language with assembly is a lot of fun because it helps you understand how things kind of work, I think. I think it's a necessary thing. Edward, a function need a label to jump and then a value to tell the program counter where to jump from, and then where to return value might be stored in a register. Oh, yep. Olivia Coder agrees with you, which Olivia Coder is our expert assembly language. Who knows? Hey, how's it going? Who knows? We are currently doing assembly language right now. We're walking through Olivia Coder's code here in main. How big is this file? It's pretty big. There's a lot going on here. Look at this, you guys. There's a lot going on. So I will have to jump back to, actually, do you have a for loop in here? How do you do a for loop in assembly? That's what I want to know. How to do a for loop. Move, eddy, screen width, screen height. Okay, ESI. So like there's just a bunch. This is like advanced for me. Like I don't know where we're at here. JZ is exit. Terminate. Loop. Is this, wait, loop, you guys, loop. Expert. For loop is also label, I believe. Yeah, it is. Yep, a label. So in order to do a loop in assembly, you just use labels. And in order to do functions in assembly, you use labels. There we go, you guys. That is so cool. And then I guess you have to know when to exit if you're doing a loop and you're constantly jumping to the loop, your update and render. Yeah, okay. That makes sense. JZ jump if zero. Jump if zero. Oh, also you have the data and data. I actually want to see your data file. I want to see your data section. Let's see. So where is that? Is it data? Data.s. Here we go. Let's take a look at your data section. So you've got includes, if defined, section, which I believe is a label. Read only data. Is that what that is? RO data? Do I have to have a section in front of RO data? Wait, hold on. We have to check this out really quick. So we had this RO data, but it has to be, does it have to be like this dot section, like this? Is that how that works? Let me know. Nope, it still does not like it. It doesn't like it. It doesn't like it. All right, we'll have to come back to that later. So we're trying to make sure that we learn a little bit of assembly language today. That's what we're doing. We're learning assembly language, and we're learning how to make things work. And so this right here, I understand this. So you've defined a title, which is a variable name, and it's a type of string. Data type is string, which automatically null terminates. And then this is the value of the string. So we know what that is. This is a label. I don't know what RO data is because it doesn't work in my program. So it's not clicking for me yet. Artur, if I recall correctly, a for loop is something like jump if not equal. JLE, jump if less or equal. Don't remember the exact stuff. Yeah, thank you for the likes, you guys. Check main and you can see me use it. Okay, let's go into main. Okay, here we go. A lot of fun with assembly language today. We're learning assembly. We got really far. I actually feel like we've learned a lot today with assembly. It's made a lot of progress. I got some of the foundations and understanding. There's still some things like this. I still don't know what .section.ro data is. I'm trying to get it to work in my Hello World program, but it's not working. Edward, hey, whenever you want to see how C++ translate into assembly, you can try CCompiler Explorer with no optimizations and maybe try adding numbers and see how the registers are used. There you go. That makes a lot of sense. Then I'll be able to essentially like decompile to assembly, and then I'll learn more about how these higher level languages use assembly or compile down to assembly. Gentlemen, gentlemen, how's it going? We are learning assembly language today. That's what we're doing. We have a Hello World application right here that we've been walking through. We want to multiply some numbers together, and we want to do a for loop. And we kind of, through Olivia Coder's help for the GL window, yeah, okay, that makes sense. With Olivia Coder's help, we are learning a lot about assembly today, which is really useful. I'll try to be here next stream. I'm really interested. Excellent, cool. Yeah, this is a lot of fun. I'm really enjoying this. So what we're going to do, though, really quick is we'll take a break from some assembly. And mul is the way to multiply numbers? MUL? Is it? Mul? I'm excited now. Let's jump back really quick. So let's do this. Let's make sure align 4. I don't know what the idea is, but quad 410. Can we do, so how do we do it? MUL, how do we do it? Actually, I don't even know how to do it. I want to multiply two numbers. Here, multiply. I probably have to do it in the main section first. Here we go. So here's the start. So let's do it over here. So we'll say multiply the two numbers defined above. Here we go. Let's spell the word correctly. Defined above. All right, here we go. And to do a single what? Prusigan, like a 1.1, use Musel to use the floating point unit, the FPU. Bull! Multi-language project is what inspired me to learn assembly. Apparently different languages use different protocols and how and what they register to use, like code conventions and named ABIs. That makes a lot of sense. There's just a ton of different ways to write assembly, you guys. Any operation with SS is signal prone floating point. Interesting. Really? All right, here. I'm going to try load the value into register X. My number, okay. My other number, X1. Okay, so you're moving X1 into the, so you've got two registers, X0 and X1. So you've loaded it. I don't know if this actually works or not. So we're gonna try it out really quick. Like you play with direct registers and assembly. Yeah. So you're directly accessing registers here. It's like this is register. You got to register. I'm pretty sure this is what this is. This is a register, right? So register 0 and then register 1. And then we've given it access to a number. And then here we want to multiply 0 together. Here we go. Like this. And then how do we print it? Now x0 contains the result of the multiplication. Print to standard out. Okay. Here we go. So we're just, this is the AI can't, the AI doesn't know. So let's actually see if this works though. I actually want to see if this works. Main, here we go. Because we don't need that. Here we go. Let's get rid of that. Okay. Build. It worked. You guys, it worked. So this is just a little bit too much for me. In order to multiply two numbers, do you really have to do it like this? This seems like way too much. Like that's a lot. Are you kidding me? Is there a simpler way to do multiplication than this in assembly? This is what I want. I want to just do this. I don't want to have to load the registers. I mean, I'd be fine, but it's just a lot, right? That's just a lot to have to do. So that build, did it run? Does it run though? Hello. It still runs. So it actually does this work, but it doesn't print anything. Check your time. Oh, okay. Let's do it. Okay. We'll check your time class. Here we go. Your time file. So let's open up time.s. Here we go. So here's time.s. Move ss. Load the time of day. Okay. So move.ss. So these ss commands are sort of like multiple steps together. So we've got a register here. I'm still trying to figure out. It's mul ss, but still. Okay. Time.s. Got it. Update the sky color. Okay. Move call address mul ss. This. Oh, interesting. Okay. So I'm just I'm learning here, you guys. We're trying something out. Subtract, multiply. Okay. But you still have these XM00s. So what is this? MV apps. Okay. So I see, this must be a different kind of register. I don't care if you believe there's specific registers that do call system depending on the value you put into and then communicate with your OS. So we need to be able to move data into operator registers, and then we need to be able to compute or use those registers to run operations. By the way, this is all floating point registers. Okay, got it. So these are all floating point registers. XMM is a floating point register. Okay, so XMM0 is a scratch register, float register. What is SINF? Hey, thank you for the likes. Appreciate it. Call SIN. Okay, where is SINF defined? Where is SINF defined? I'm actually kind of curious. Is that, and all the XMM numbers are floating. Oh, there you go. So like all these SS's and the MMs. Oh, really quick, call SNF. Okay, call SNF. Let's see here really quick. I'm going to grep-r or just grep synf. Or how about inf? No? Oh, I'm in the wrong directory. Here we go. CD src. All right, grep synf. Here we go. Star. Okay, so mesh. So, interesting. It's also in your camera. Call synf, call fence, but it's defined. Where is it defined? Is it defined in mesh? All right, this is x86 though. How did you learn assembly? University or self-taught? I learned how to do a multiplication, which we solved that. A multiplication. Self-taught, cool. Yeah, Olivia, that's like the best way. I would say the best way to do it is self-taught. And then, excellent. So we've got our start here. We did some math, which I believe works. So we've got mult, and then so we want to print x0 to standard out. Let's do that. Do we have to convert it to a string? I don't want to convert it to a string. Let's see here. Do we have to? I don't know. Well, I guess let's see how it goes. We'll use a simple method. I don't think my Copilot is understanding what to do here. Write x0 to standard out. How about that? No. Convert the number. No. Okay. So I don't know how to do that. I don't know actually how to print anything here. I'm getting send functions from the math lib provided by the OS in the lib. Oh, got it. So that's where it's defined. That makes a lot of sense. So we are just learning some stuff. So I know how to print a string here. So we've got a string. We know how to page on X1 is the page address of the hello string, and then the length of the string, and then invoke a system call to register 16 number 1, which is I don't know. It says exit, but I don't know. Exit status 0. Oh, we're ending. This is the end. Okay, so that's not the print. The print for the hello world is I believe, where is that? X0 is 1. So as x0, you have to do the change in the end into a, you do have to change the integer to a string. You do have to change the integer to a string. But the cool thing is, I do believe that this counts as multiplication. It didn't crash. It seemed to have worked. But so I still want to do that. Store it in a buffer. How do we do that? This is what we have to do. We'll have to do it next time because we're running out of time. But really quick, so we've got Olivia, coder. You were MVP today. Thank you so much for sharing your code. You did a really great job walking us through assembly language. It was really appreciated. It was a lot of fun working with you today. I learned a lot. It was great. This was a really great experience for me. It was a lot of fun. And we'll be resuming our assembly tomorrow. Learn with us, and you participate, you join in, and you ask questions. Enjoyed hanging out with you and learning some assembly language. It was good.